As you've seen with the last few examples, graphing systems of equations can be an easy way to find the answers. In this example, we're going to graph with our calculator to find that solution. The instructions on how to do this are found on page 615 of your workbook. To start, we need to take each of our equations and rewrite them in the form y equals mx plus b. Your calculator can only take in equations that are in the form y equals something, so we have to do this step anyway. So for this first equation, we'll write it as y equals negative 3x plus 11. And for the second equation, I've got 3y equals negative 2x plus 12. And again, we have to divide everything by 3. So y equals negative 2/3 x plus 4. So using your graphing calculator, we can enter those equations in the y equals area. Don't forget to make sure your calculator is in function mode. It's the fourth option there. Mine does default to function mode, so I don't have to change this, but it's nice to just check and make sure that's okay. So for my first equation, y equals negative 3x plus 11. And my second equation is going to go into the second line. If you want, you can use your cursors to move to the left of the y2, and by hitting enter once, it'll show your second graph with a dark line rather than a thin line. So we'll get a thick dark line just so you can tell the difference between the two graphs. And then the other tip is, don't forget, whenever you have a fraction and you're entering it in your calculator, to put it in brackets, so that negative 2/3 x should be negative 2/3 in brackets x, or negative 2x in brackets divided by 3. I like to just keep my fractions in brackets. So the next thing I do is I graph the equations by pressing graph. And you'll see that thin line is my first graph, the really dark thick line is my second graph. So to find the solution, I need to find the intersection point. When we had a grid that we drew these on, we just manually counted that off, but your calculator has a feature as well. You'll have to hit the second function key and then trace. So second function trace. We're going to move down to option 5, find the intersection point. So I just move down to it and press enter, or just hit 5 and it will automatically do this. Now what the calculator is going to ask you to do is to click your cursor somewhere on the first graph. Now I can't see my cursor yet, so I'm just going to use this arrow until it's there. Now I see it, it's sort of flashing. So anywhere on the first graph, I hit enter. Then it moves to my second graph, and you don't have to move it. Anywhere on your second graph, you hit enter. And then there's this guess feature. For linear equations, it's maybe not as important to guess, and you might still get the right answer. But in the future, you may graph lines that intersect more than once. So it's really important that you move to the intersection point you're trying to solve, and then hit enter there. That's where we're guessing that they intersect. And I get two values back at me. X is 3 and y is 2. So the solution for this equation is x equals 3 and y equals 2. And y equals 2. Part C asks you to state a suitable window which shows both the x and the y intercepts. In this case, I haven't adjusted my window settings at all. You can see they go -10 to +10. And my y is -10 to +10, and both have a scale of 1. That's called the standard window setting. If yours doesn't look like this, you can hit zoom and choose number 6, standard. So I've chosen -10 to 10 on a scale of 1. In each case, that's a standard window setting, but you can adjust it and get closer, and as long as the intersection point is visible, then you're okay. So for my x's, I go like this. My minimum value was -10, My maximum value is 10 and a scale of 1. And for my y's, I used a minimum value of 10, maximum value of 10, and a scale of 1. If you forget which order to write that min-max scale, it's available on your formula sheet. So we have solved the system of equations. We do know that the value for x is 3 and the value for y is 2, and you're done.